Okay, we are going to discuss this further math question. It's a vector problem involving vectors. We're going to see how to use vectors to solve problems involving mensuration. The question says, find the area of a parallelogram whose adjacent sides are 4i plus 3j plus k and minus 5i plus 2j plus 3k. The I, j, k are the unit vectors. See what happens. Let the vectors representing the sides of the parallelogram be A, vector A, have you seen it? Is equal to the first one here, that is 4i plus 3j plus k. The other side of the rectangle, of the parallelogram rather, B, have you seen it? Is equal to the other vector minus 5i plus 2j plus 3k. The area of the parallelogram is the magnitudes of the vector product of these two vectors. How do we find the vector product of vectors A and B? It is vector A times vector B as in vector product equals. Now the determinant of a 3 by 3 matrix taking the unit vectors first, that is I, J, and K. The coefficient of I in the first vector here is 4. Of J, it is plus 3. Of K, it is 1. For vector B, the coefficient of I here is minus 5. Put it under here. Of J, it is plus 2. Of K, it is plus 3. Now, when we find the determinants of this matrix, what we have is the vector or cross product of vectors A and B. This will give us, taking I vector, this is 3, 1, 2, 3, minus this unit, J times 4, 1, and minus 5, 3. Plus this, taking K now, units, this, 4, 3, minus 5, 2. 4, 3, minus 5, and 2. Evaluate this. So give us I, isn't it? Times 3 times 3 is 9. Minus 1 times 2 is 2. Determinant, remember? Minus this unit here into 4 times 3 is 12. Minus 1 times minus 5 is minus 5. Intentionally, I'll write minus 5 here to avoid confusion. Plus K unit into 4 times 2 is 8. Minus 3 times minus 5 is minus 15. Intentionally, right? Minus 15 there. Have you seen it? To avoid confusion. This is equal to I unit into 9 minus 2 is 7. Minus J unit, 12 minus 5 is 12 plus 5. Because minus times minus is plus. So we will have 12 plus 5. Is that right? That is 17. Plus unit K into 8 minus 15 means 8 plus 15, because minus is minus times minus is plus. So 8 plus 15 is 23. 23. Have you seen it? We simplify further. This gives us 7 times I is 7i minus 17 times j is 17j plus 23 times k is 23k. Now, to solve the problem, we want to find the area of the parallelogram. The area of the parallelogram, that is, area of the parallelogram, is equal to the magnitude of the vector product of these vectors. The magnitude as this, watch it, this A times B. And as it done, is equal to the square root of Look at this one here. Have you seen it? This 7 squared plus the quotient of j is minus 17. So minus 17 squared plus the square root of the quotient of k is 23 plus 23 all squared. We evaluate this. 7 squared is 7 times, so that is 149. Minus 17 squared is minus 17 times, it is plus 17 times 17. Let's do it out. 17, 17. 7 times 7 is 49. Carry 4. 7 times 1 is 7 plus 4 is 11. 1 times 7 is 7. 1 times 1 is 1. We'll have 9, 8, and what? 2, that is 89, right? This plus 2, 89. And 23 squared is, as before, 23 times 23. 3 times 3 is 9. 3 times 2 is 6. 2 times 3 is 6. 2 times 2 is 4. Have you said it? This is 9. 6 plus 6 is 12. 2 carry 1. 1 plus 4 is 5. 5 to 9. Here is 5 to 9. The sum it all will have this as the square root of 49 plus 2, 8, 9. 4, 9, 2, 8, 9. 9 plus 9 is 18. 8 carry 1. Have you said it? 1 plus 4 is 5 plus 8 is what? 13. 3 carry 1. 1 plus 2 is 3. Have you said it? Now, plus 5 to 9. This is 5 to 9. Let's go. 8 plus 9 is 17. Carry 1. 1 plus 3 is 4 plus 2, 6. 3 plus 5 is 8. 8, 6, 7, right? So everything becomes 8, 6, 7. Remember, we're talking about the area. So you're going to work in square units. The square root of S67 squared units. That is the answer to the question using the knowledge of vectors, right?